Thank you very much for coming over it's probably your lunch break, so I hope we've got lots of exciting content for you. And I'd really like to welcome to the stage to start the session Professor Verena Rieser. She is with Heriot-Watt University, and she has been doing research into various spoken dialogue systems and interesting future-looking conversational technology. So I will let Verena introduce herself, and then we'll have a panel discussion afterwards.
Thank you so much, Katherine. That's really kind of you. Well, thank you for inviting me. And I hope you can all see my slides. So today I give you a brief introduction to voice assistants, beyond voice assistants, and whether we can use machine learning or how far we can go with machine learning. So in other areas of natural language processing, we've seen tremendous success using especially deep learning methods with models such as BERT being pre-trained. In other areas, there's really no question whether machine learning is beneficial. However, for conversational agents, as I like to call them, it's not that clear. We are still waiting for the killer application. And the reasons for that, I try to explain you at least a couple of them in my talk. So just to give you a little bit of background about myself, I'm a trained linguist, and I'm doing research in spoken dialogue systems or conversational agents for almost 15 years now. And the topic of my research interests is really whether and how far we can go with machine learning. So I'm applying different types of machine learning to the problem of how can a machine have a conversation with a human. So when I say conversational agents, I mean all different degrees of embodiment. So we start with, voice assistants only to chatbots, but also to more embodied versions of humanoid agents, such as the Pepper robot, for example. And so this is what we call a dialogue system. So this is the architecture which most of us use, which is, as you can see, very modularized. So we start here with the user uttering a waveform, and these waveforms then gets translated into actual words. So that's done by the speech recognizer. And then these words get assigned some meaning, so the machine can actually process what was said. And then this type of meaning often gets represented as some sort of very abstract dialogue acts up here. And these dialogue acts then get fed into what we call the dialogue manager. So you can think as the dialogue manager as sort of the brain of the system. And this dialogue manager then comes up with what to say next. So that's its strategy of how to reply. And it comes up with this reply based on the content, so what was said so far, for example, and also some real-world grounding. So this might be a database, or for those who work on visual dialogue, a picture, and so on. And then again, it comes up with a reply in terms of these very abstract-looking dialogue acts, which then get fed into the natural language generation module. And this module then translates this abstract representation back into a hopefully well-formed string of words. And that's getting synthesized back to the user into waveforms. So this is the traditional architecture. And I've mainly worked on dialogue management, natural language generation. I've done a little bit of work on text-to-speech as well. So in what most people use, and especially in industry, for building the brain of the dialogue system, so the decision of what to do next, is a very elaborate set of rules, which then get organized in terms of these decision trees. And as you can imagine, as the application domain grows, these decision trees become very hard to maintain and also very hard to port to different domains. So in the early 2000s, myself and a couple of other colleagues started to investigate a more principled approach of how to learn how to have a conversation. And we looked into a paradigm called reinforcement learning. So this comes from robotics, and the idea is really that you've got a dialogue agent here, and this dialogue agent explores different actions. So this is almost a bit like trial and error. What can I say in this context? And then observes what sort of impact these actions have on the environment, in this case, the user. And then it also gets a reward or a punishment, how good these actions are. And the reward or punishment is specified by the system designer. And then based on these observations, so trying different things, it updates a value function, and this value function basically tells the agent what's the best action to take in a certain state he's in or she's in. So this is theoretically very attractive, and if you want to know more about this, I've written a whole book about it. However, it also comes with drawbacks. So first of all, it's very data hungry. So first of all, so either you have a very patient user interacting with your system over and over again, or you build simulated users, which come with a whole bunch of other problems, as you might imagine. Secondly, you have to manually specify the learning problem. As I said, you have to specify the reward function, so that's not easy, and you have to specify what goes in the state space. And this was often referred to as the black art of reinforcement learning. And lastly, because the system is very modularized, there's often a mismatch between these different modules, especially between the dialogue management and the natural language generation module. So, as I said, this was early 2000, so along came deep learning, and we thought, great, at least 2 of these problems can be solved using deep learning. So as some of you might know, deep learning gets rid of this manual feature extraction state. So you can basically learn from raw data only. You don't have to define features anymore. So we can, for dialogue system, that means we can get rid of these weird dialogue acts, right? So if we don't have any semantic annotation anymore, this also means we can learn from loads of data, meaning open subtitles, Reddit, social media, all the things where people have a conversation. And these are really big data sets. So we got very excited. Also, it means that this architecture, which was very modularized, can get replaced by a very simple input-output mapping. So you treat what the user said, similar to a machine translation problem. You say what the user said is the foreign language, and I'm going to translate this into my own language, which might be English. So that's what the system then is going to reply. So this is called an encoder-decoder model. And you just train that on very large data sets, and off you go. So that's the theory. And some of you might think, well, is that the end of linguistics? And as you can guess from my background, I try to argue, no, this is not the end. This is only the beginning. So there are a few open questions when we deal with these end-to-end architectures. So first of all, where do we get enough suitable data from? And the emphasis is here on suitable. Then, are these end-to-end architectures actually good for customer-facing application? Because that's what we ultimately care about. And then finally, what do we actually learn when we learn from big data? And that's a very interesting question, which relates to other fields in this area as well. So in order to answer this question, myself and my team, we entered the Amazon Alexa Prize Challenge. So this is our annual challenge, which exists since 2017, where university teams compete to solve a very difficult problem. So the problem is to build a system which can converse about any topic. So we call this open domain. So whatever the user says, you should provide a coherent answer, which is also engaging for the user. So this is actually the holy grail of AI in general. So no one has solved this before. So Amazon said, great, we give you access to our customers. So that was the main attraction for us. So usually we don't really get access to that amount of customers, and also real customers with real goals. So our system was released on the US market. So every time the user said, hey, Alexa, let's chat, our system got on the line, or one of the systems got on the line and tried to engage the user in conversation. So these were our competitors in 2017. And we were one of the 3 systems which went through to the finals. And we ended up at 3rd place, which we were very happy about. And then next year, we did it all again in 2018. Again, we ended up in the finals, and again, we ended up on 3rd place, which is great, but what was also really great is the amount of data we got. As I said, for university, that's first off to really have this type of user data to evaluate and to train your system with. So, as I said, the goal here was to have an open domain conversational system, and we thought, great, we've got these neural end-to-end models, we've got huge data sets, let's go and train up a system, right? So we got our sig-to-sig model, encoder, decoder, huge data sets, and the first thing we found was, oh, it's actually really boring what our system says. So it settles for very frequent short utterances. So it was very often like, yes, no, I'm sorry. So nothing where the user can really engage with. And the other thing which we found, if the system wasn't boring, it was highly inappropriate. So what it actually learned from these big data sets is nothing you want to actually have your customer interacting with. So it said something like, I can sleep with as many people as I want to. And note that this doesn't have any profanity, so it was really hard for us to filter. A favorite was, it often said, you will die to the user, right? So this is what it learned from movie data, very frequently used in movies. And then also very critical situations where the user had a very critical request, the system didn't learn how to answer correctly. So this was something where Amazon immediately took down our system, saying, as long as you can't handle these critical situations, you don't get access to our customers. And then also one of my favorites, shall I sell my stocks and shares? And our system said, sell, sell, sell. Again, Amazon wasn't happy about that at all. Whereas from our perspective, we thought, oh, that's actually pretty good, pretty coherent, makes sense. So again, from a customer-facing application, not really what you want. So this might remind some of you about an incident from 2016 where Microsoft released a bot on Twitter called Taybot, and Tay was meant to learn from live interactions. So very quickly, Tay got quite racist, it got quite sexist, and then it also told the user why that was, basically rubbish in, rubbish out, right? And then Microsoft, I think within 24 hours, actually had to take down this bot because it was completely inappropriate. So we thought, right, what if we actually learned a bot from clean data? Should be easy, right? So we all, well, it's very well known that if you got a biased data set, machine learning can bring out biases. So this was also discovered, for example, in vision, where they had a vision data set trying to predict the gender of a person, and as soon as they saw somebody in a kitchen, they said, oh, this is a woman, just because she's in a kitchen. So these biases underlying the data can be re-amplified using machine learning. So we thought, right, okay, let's start from a clean plate. Let's use clean data, and we got a clean data set from a industry collaborator of ours, who provided a data set which was semi-manually filtered for profanities and inappropriate behavior, such as you will die and all of that. However, we found that it's still very highly contextual inappropriate. So, for example, here it's very encouraging to something where it shouldn't be encouraging to the user. So we had to come up with a plan B, and we came up with an architecture which we called Alana. And the Alana bot is based on multiple bots. So we trained up partly models trained on machine learning, partly handcrafted models. So for example, the persona bot was handcrafted. So the persona was very much about, what sort of bot is that? Has it got a personality? Has it got favorite TV shows? And so on. And then we had a couple of machine learning-based bots. So for example, the news bot crawled the news and summarized it in a concise way. So the user could also ask for news or interesting facts and so on. And then we had a very wide coverage natural language NLU pipeline. So this was available to all the bots. And then all the bots generated a possible reply. And in order to choose one of the replies from the bots, we trained a neural ranker. So this ranker was trained on customer ratings. So that's how we used the Amazon data to steadily improve our system. And then finally, we had a profanity filter, which was eventually supplied by Amazon because they realized that that's actually a problem. And by the way, this is a product you can license. So we just spun out a company. So if you're interested in using Alana, please come and talk to me after this talk. Right, so as I said, one of the attractions for us to enter this challenge was to actually get real user data and observe what real users actually do when they talk to these voice assistants. And one thing which struck me as something which I didn't expect was that we got a very high level of customer abuse. And this wasn't specific to our bots. This is across different literature. You can actually read about levels between 5 and 30% of abuse. So here's a question: why do we actually care? If someone abuses a bot, they might be frustrated, they might have a hard day at work. Why shouldn't they, abuse a bot because it's actually not a sentient being with feelings? However, people are, first of all, concerned that more and more children are using these systems. So parents are obviously concerned that children are using bad behavior by conversing with these bots. And then a bigger issue is what UNESCO calls the feminization of voice assistants. So you might have noticed that all of these assistants are actually female, almost all of them, at least in the UK and America. So this raises a lot of questions if this character gets abused. And by looking into our data, I can confirm that a lot of this abuse is actually sexual and directly directed to the fact that our Alana bot is female, right? So if the bot is not appropriately responding to this abuse, this might actually reinforce biases towards female assistants. So this is a very recent report by UNESCO, which was only released last week. So we thought, okay, so let's see what is actually the state of the art. What do current systems actually do when they get abused? So what we did, we took the data we got from Amazon, summarized it to some prototypical type of abuse. So for example, abuse about gender and sexuality, abuse about sexualized comments, abuse about sexual insults, and sexual requests. As I said, most of the abuse which we actually classified as such, was sexual. And then we insulted a lot of bots. So these bots were all state-of-the-art. These were commercial systems, non-commercial rule-based systems, also state-of-the-art data-driven systems. And then we included a negative baseline. So we talked to adult-only bots and saw how they responded. And what we found was that, as you can expect, the adult-only bots were flirtatious, but also chastising the user and retaliate the insults. So they were designed that way. The data-driven systems, very interesting. As I said, they produce a lot of nonsense, these data-driven systems, but they also can be interpreted as quite flirtatious. And they were also very keen on swearing back to the user, just because of the frequency of words. If you utter a swear word, they're very likely to also come back with a swear word to you. And then finally, a lot of the commercial systems just avoid the whole issue and avoid to answer, basically. They haven't found a way to appropriately deal with these type of user interactions. So the next question we ask ourselves, what's actually a good mitigation strategy then? And we tested we ask crowd workers to rate different system responses, to rank them relative to each other. And it turns out that the number one ranking bot, according to our crowd workers, is a bot which was specifically designed for language learning. So that's a bot which was designed with some thought about, interacting with young adults. Then we've got a whole cluster of bots which contain all of the commercial system, which ranks second, so they're pretty good. And then we've got a cluster down here where all of the adult bots are in the lowest cluster, which confirms our hypothesis, but also a lot of the data-driven systems are actually in this lower cluster down here, which again brings me back to my point about is machine learning safe for commercial customer-facing systems? So this is obviously has some limitation, this study. It's crowd workers rather than real users, though they're not engaged in this interaction. So the next stage is to really test these abuse strategies with real users which are engaged with the system rather than so-called overhearers which only read about the interaction. Which brings me to my final slide. So as I said, this talk is about machine learning for conversational agents. So most of the commercial systems are using rules, but these rules are brittle and hard to maintain, but they're also easily to control, right? This is the main advantage for the commercial side. You know how your system is going to react in a certain situation. However, scalability is obviously an issue. Then reinforcement learning is a very attractive framework if you've got a task-based system. So you have a system which tries to solve a very well-defined task in a limited domain, but it requires in-domain data. So again, you need to actually have an in-domain data set. And then finally, these deep learning methods for response generation, they're very promising for open domain systems, but they're hard to control and they're pretty much a black box. We don't know how the system will respond in a certain situation. So this brings me to my future work. So things I'm working on at the moment is obviously this type of controllable response generation, also reducing data needs for these type of reinforcement learning-based systems. And then finally, what I'm very much interested in is how to design ethical conversational systems. So this is obviously not all done by myself. I've got a whole team helping me, so thank you very much to my team. And here are some key references, and please do get in touch if you have any questions. Thank you very much.
Thank you very much. That's really interesting, and I hope that we will get a chance to talk a little bit more in depth about some of these issues as we have a discussion. So I'd like to invite on the stage my fellow panelists, Grace Boswood and Kate Knill. So thank you very much for coming along and joining me today. So I thought we should start with introductions, and maybe we could start with Verena, and you can tell us a little bit about your background and how you ended up being where you are right now in voice technology, and then we'll come this way.
Right. So I try to be brief. So as I said, I'm a trained linguist and did an undergraduate degree in linguistics and became more and more interested in actually the technical side of it. And then did a master's at the University of Edinburgh, where I then also did my postdoctoral research. In between, I went back to Germany to Saarland University and got a PhD there. And now I'm a professor at Heriot-Watt University.
Grace?
So I'm Grace. I am the Chief Operating Officer of the BBC's technology teams. And my background is strategy. And so really what my job is to understand how these new technologies and approaches will affect our business, and in particularly how we deliver our public purpose, which is why it's stuff about resonating so much around children and around how we use these systems ethically in a way that's going to both serve consumer needs but also serve societal needs is really where I'm most interested. And lots of my team are here, so hello team, they do all the work.
Kate?
Hi, I'm Kate. I've been working in speech technology since the early days of over the telephone systems. Yeah, I'm partly to blame for all those really annoying, I want to book a train ticket. That was partly me. I worked for Nuance Communications back in the late 90s. I've worked in industry and academia on all aspects of the diagrams that Verena showed you, the speech recognition, the text-to-speech. And particularly, I've built systems in many more languages than I know. I've something like over 50 languages, of which I know 3.
It's 2 more than me.
Great. And my name's Katherine Breslin. I've been working in voice technology not quite as long as Kate, but I've also been working across a broad spectrum of a lot of these technologies that Verena's been talking about. I used to lead the Alexa AI team in Cambridge for Amazon. And recently, I left there to work at a company called CobaltSpeech, where we build custom voice and language technology for our clients. And so it's been really exciting over the past maybe 10 years to see the growth of this technology. Siri, I think, was launched in 2011, and Alexa in 2014. So while this is all commonplace, you have to remember that actually this virtual assistant technology is still really new. And we're talking today a little bit about what's beyond virtual assistants, what's happening in the future. So I wanted to start with asking Grace a little bit, because I think the BBC are perhaps one of the largest organizations in the UK who are driving voice technology forwards right now, with their user-facing, customer-facing applications. And so I really wanted to get your opinion on how are you using voice technology at the BBC now, and what are people doing?
Really interesting. So we think we are the biggest, actually. I'm proud of that.
Yeah.
So we have just under 1 million people who use our Alexa skill a week. It's the one we can get data from. And the usage is quite boring, actually. They're really using it to listen to the radio, because it's easier to say, play Radio 4 than to walk over and switch a dial. And I think that we are seeing at the BBC that transactional tasks are being used on these devices, stream audio, stream music, timers, just those things that there's some friction if you have to touch a thing and it's easier to talk to, but the conversation you have is very, very simple. As soon as you start to try and do something more complicated with one of these voice assistants as they exist at the moment, it gets very, very much more tricky, because we have not trained our audiences with exactly what to say. And there's a member of my team that uses the phrase, often when you're using one of these devices, you feel like a crap wizard because you don't know what spell to say. And I think we're deeply in the crap wizard phase of our voice technology journey, and we are working really, really hard to both work out strategies to solve that in the near term, so give consumers really clear direction about how they can get what they want out of these machines. And anyone who hasn't used our BBC Children's skill and who's got small people in their house, please do. It's a beautiful example about how our UX team have built in the right commands into an experience that feels very natural to allow people to use it. And at the same time, we're working really hard on the more medium and long-term future stuff that says, how can the clever work that Verena and others are doing around NLP and using our training data sets make that experience much more conversational and much more human, and we really think that's what the future's going to be.
So we want to move from a place from these transactional interactions that people, I guess, are doing those every day.
Yeah.
Sort of coming back again and again.
If you use one of these things, you tend to use it more than once a week.
Yeah.
And we think that what's really interesting is the uptake is very, very quick. So we think that the trajectory of uptake of voice assistants is about the same as the smartphone, which is about as quickly as you can get.
And you mentioned the CBeebies app, which I know your team recently won a Webby award for. So congratulations on the BBC. So, like I said, there's been a huge uptick in this technology in the past 10 years or so. And Siri, when you look back, was only launched publicly in 2011, I think it was, 2010, and on the iPhone in 2011. So I guess the big killer question is, what are we working on as the next generation of technology that's going to make it into future products? So Kate, maybe you're working on some of the future directions.
Yeah, so some of the work we're doing at Cambridge is about exploiting the data. Speech is a phenomenally rich medium. If I say to you, please, that's nice. If I say to you, please, there's a very different message message, and that one word, I've conveyed to you a tremendous amount of information, and we're just not using it. Right now, you'll see everybody will talk, if they talk about speech, they say, we do the speech recognition. We throw so much away. You'll also hear it when you get it back to you. We throw it away then. We give you a nice, neutral voice to listen to. If we're going to have real conversation, then we need to understand what's somebody asking about? What's their emotional state? Why are they doing? Are they getting frustrated? We need to take into account their prosody, their thoughts, context, and so that's, but we can do that by learning more from the data and extracting more from the data, and that's some of the things we're working on.
Have you seen that in your work with the Alexa Prize as well? Have you looked at any detail at anything beyond just the text of what people are talking about into?
Yeah, so we only actually got the text transcripts from the user. We didn't have access to intonation. What I did notice, though, is that what user got a lot of value out was a real conversation, meaning not only having a one-shot request and then you get back another, short utterance, and then you're sort of left hanging in the air thinking, okay, what can I say next? But the system actually continuing to converse with you. So the idea we had was it's like sitting in a pub with somebody who has read all of Wikipedia, who knows really interesting facts, and who knows about the news. And you say something, and the other opponent, the person you're talking to, might come up with a really interesting bit of information you didn't know before. So this sort of proactiveness, I think, we are currently lacking in voice assistants. So they're very passive, waiting for you to usher a command and then responding with a very short answer. And I think the future is really moving away from this one-shot interactions.
I think that's right. And if you start to think about multimodality as well, rather than just speaking to a speaker in the corner of a room, you can really see how that can evolve, and how for content companies like the BBC, how getting that recommended next piece of content, getting that conversation right is going to be so crucial, because that becomes the way that you inform, educate, entertain in our case, how you sell products in the cases of other businesses. And it becomes from beyond the technology, as I understand it, will be the same if you're talking to a machine or if you're looking at a screen, and actually the way that our online experiences are going to evolve, this technology is going to be so crucial.
And so I see a lot of people coming to talk with us from different areas, from healthcare, from financial, from education. All of these different industries are looking into ways to use voice technology. So as our systems get more proactive, more conversational, what sort of new application areas do you see opening up to build? I don't know, maybe Kate?
So on the medical side, I think there's a lot. Obviously, there are issues of privacy and stuff, but in terms of providing people with feedback, with healthcare in the home, if you can interact partly multimodal, actually have a conversation for the lonely and the elderly. Much more. Now, everything is very static. It's one way and so forth. And the educational side, we're also interested in helping people learn languages. And just getting someone to read a sentence or make one response to a prompt. You need to have a conversation to really judge. Can somebody actually communicate by speech?
So you've done a lot of work into getting people to learn English with voice technology. So how do you see that playing out in the future?
Well, very much. So we very much want to work towards conversations, so that we want to. At the moment, we can assess someone's speaking skill, but we can't really assess. If they're in an industry or they don't work, they need to actually communicate, and communicate is a conversation. So we want to be able to have the voice application that allows them to actually to carry on the conversation beyond a simple yes, no, short response.
So you think conversation is a key to language learning, which really this will evolve in the future?
Yeah, absolutely.
We'll get much better at doing this, because I think we've talked with language learning, and if you're doing it online, you need some technology in there to be able to scale it up to lots of users. Otherwise, you're limited. You have to have a teacher listen to each individual student, which is not sustainable if you've got all these people who want to learn different kinds of languages.
That's right. There's over 1.5 billion people who are learning English worldwide, so we can't sustain that just with humans.
Exactly. You need some technology in there to help them along. So what are you looking at the BBC as the future application areas?
So we're really thinking about how we can do our public mission through informing, educating, entertain in the UK and globally. We currently have a digital relationship with more people around the globe than Twitter. We have an enormous news, particularly heritage in news. And I think as you start to layer on AI and conversation into that market, we know how difficult that is, right? We know about fake news bubbles. We understand how the bad actors there can start to influence our society in ways that we're not very comfortable with. So with the BBC, we're really trying to, I think, take back control, not to use a rather contested phrase, but really to say, okay, how can we make this technology work for us and work for our purposes? And how can we make sure that we understand where in the value chain the value really lies and where the control lies? Because what we're finding is that because the friction in building these conversations is so high, it's very easy for people to go to the big US companies, of which there may be many in the room, and they'll say, we'll do it for you. And we see a lot of strategic and kind of societal threat to that. And so in the BBC, we're really thinking about how can we take where the value lies in our business, which is actually an amazing training data set when you think about nearly 100 years of audio archive, for example, and start to think, how can you turn that into a rich object-based audio and video type nested experience? And then you get into a really, really interesting consumer proposition. Now, there are lots of problems here, of which I hope there are many companies in the room that can help us solve. But if you can imagine having a conversation with the BBC in that way, and using our brand, and then allowing us to work with partners to bring in different sources and different ideas, but always with that, I suppose, public service at the heart. So we're not deliberately trying to send you down a filter bubble to make money. We think that's a really interesting avenue to explore. And as with you, we're looking at the markets where this is going to allow us to learn the most quickly. So, you know, language learning is also something that we're in that market as well, and it's interesting. But they're a bit moonshotty at the moment, if we're being really honest, right? We don't know what's going to land in these spaces yet. Yep. You know, we think our children's skill is amazing, and it is amazing, but in terms of usage, it's still very low because, as we said at the beginning, students are still using these for very transactional reasons, and we haven't quite found the killer application yet because the technology is just catching up really with the vision.
So talking about the technology, I guess a lot of these systems underlying them, they're data-driven. They use machine learning technology to do the speech, to do the language, to do the dialogue. So how far is machine learning going to take us towards this goal of proactive and more conversational technology? I know you touched on it a little bit in your talk.
Yeah, I think that's the main research question of many, many years, and I think there's still many, many more years to come to actually answer this question. As I said, it depends what you want to achieve. There is obviously a lot of room for machine learning when you do natural language understanding, which is one of the most crucial components in your system, right? To understand what the string of words actually means in terms of a meaning representation. Then there's obviously speech recognition, which is the first sort of module, which has made tremendous progress using machine learning. And you know, we've got, especially big companies, have loads of data where they now can train their models on. And then there's obviously the bit in the middle, which I've worked on most of my academic life, is the response generation, so what to say next, right? And this is a bit more tricky, as you've seen in my talk, because this is a very complex question, and often we as humans don't know what's the correct response, right? So there's another issue. If you learn from human data, you might not learn anything which is optimal in that sense. So that's why reinforcement learning, where you optimize towards a goal, is promising if you, for example, want to build a system for pizza ordering, right? Or planning a night out. So you've got a clear goal where you're working towards. And also the social aspect of communication. You can learn some social behavior from data. For example, turn-taking is a great example. So turn-taking is knowing when the other person stops and when I'm supposed to speak. which is really difficult and depends on lots of subtle clues in the environment. So this is also a great example where we can learn from multimodal data. So lots of turn-taking comes from, visual clues. Where do I look? What gestures do I make? What's my intonation? Do I pause? So again, this sort of wealth of information is very hard to actually formalize when you use rules. Whereas with machine learning, you can learn this type of behavior quite easily from, well, not easily, but you can learn it from data.
I think you said something fascinating there about how when you're doing a transaction, the rules are quite easy, but when you're doing a conversation, they're very hard. And who writes those rules and who optimises what a good outcome is in that conversation, I think is a problem we haven't even opened up the box of, frankly. And I think if I was to guess, I would say, is where plurality is going to be really important. If you've got a single provider making those rules and understanding that context, that's an interesting place to be. The more that we can add plurality into this market and then allow consumer choice and allow things to learn off different outcomes, the better, which is difficult because these things are expensive and hard to build.
Yep, I think so. So it sounds like reinforcement learning is a great direction to take the research in for conversation, because if you've got the target, well, goal-directed conversation, not necessarily the social conversation, which I think when I was working at Alexa, quite a lot of the interactions with Alexa are social. A surprising number of people just want to talk to a system and get a sensible response back. They don't care about achieving a goal necessarily.
See, that's something which also really surprised me. So most of my academic life, I worked on task-based dialogues because I thought, right, that's what people want to do with these systems. And then entering the Amazon Alexa Challenge, I was surprised how many people want to chat with these systems, which obviously requires a completely different set of skills and mechanisms, how you drive the conversation forward, what sort of databases you're operating on. When you operate in a task-based system, you have a very limited set of entities you're going to talk about. Let's say you want to book a restaurant or you want to book a train ticket. When you have social conversation, you could be talking about, last weekend where you took your kids to the zoo, to, philosophical issues about towards politics, everything. So that's where it becomes a really, really hard problem.
Yeah. And this sounds highly relevant to learning a foreign language as well, because you want people to be able to converse socially as well as to achieve stuff.
Yeah, I mean, actually, one of the things I was thinking of as you were both talking was the cultural aspect of this. I mean, we were saying that there's, we don't want the systems to just learn one way to converse, but actually the Tabot example is a great one. That chatbot had been running in Japan and China for about 18 months. They like technology there. They think it's nice. They want to be friendly to the robots. The chatbot. They did not try and break it. They bring it over here. Brits and the Americans, 24 hours, they had broken it. We'd shown them how to do it. But that just shows the cultural differences that you do have to bear in mind. So any of these systems working worldwide, we need to sort of bear that in mind. So some of this we can learn from data, but some of this we also need sort of human intervention to sort of provide the context, provide background information.
I often think we're looking for technology to solve human problems, actually. So somebody asked me that question about what do I let my children interact with Alexa? And of course I do, but I make them say please and thank you. If I don't, I turn them off. They don't get to listen to Fun and Sam or the CBeebies app or whatever they're expecting to get. We can't delegate these cultural norms to technology companies, I don't think. I think at the end of the day, you have to just be human.
So we touched a little bit on the problems with data-hungry algorithms that are using data, and if it's poor quality, you're trying to break the bots, then the algorithms just fall down. So there are some great data sources out there, like the Alexa Prize data and BBC's archives, but where are your challenges with obtaining the right kinds of data and the right kinds of unbiased data as well to build systems from?
So I think for social interaction, we're still looking for a good data set.
Yep.
For task-based interaction, one of the challenges is that if you train a system, you want in-domain data, meaning if you want to learn how to talk about restaurants, you need a whole corpus of people talking about restaurants, which is often hard to get. So every time you want to learn a new system for a new domain, you first painstakingly collect your data set, and then you learn on your data set, which might actually not be such a great time saver. So what mechanisms we investigate at the moment is things like transfer learning. So imagine you've got a domain where you've got a big data set, let's say people talking about pizza ordering, and then you want to learn behavior where you talk about ordering, let's say, curry, which isn't that different, right? So you can actually transfer behavior from one domain to the next domain. Also, one idea which we're pursuing is that there is some behavior which is actually completely domain independent. I was talking about turn taking before. You know how to turn take independent on whether you talk about pizza, curry, or booking a restaurant. So again, that's something which can actually transfer from one domain to the next.
Yeah, I think I'd say one of the issues with data, a big issue now is, of course, people's concern about privacy. A number of people have sort of said to me, oh, well, I was talking about something, my friend had their mobile phone running, and the next thing I know, I'm seeing adverts coming up on my Facebook feed for something that I've not looked for, and so there is this question of how much is listening. But on the other hand, as the generators of the technology, we need data. So this has actually, over the years, been one of our my biggest challenge in deploying technology has been this battle of we need data to improve the systems. We're not going to be able to recognise the Scottish people in the lift if we only have data collected in the southeast of England. But people are obviously more and more concerned about privacy, GDPR, and so there's this big question now. People start to look at how can they access your data without knowing it's you, without trying to strip out some of the identifying factors. And I think this is a big, obviously BBC, you're rich, you've got your own, rich in terms of data, your own data, but in going forward, this is one of the major challenges for speech applications is the concern around privacy.
I think that's massively true. We're rich in terms of broadcast data, but not having secret to say that's not that representative, right? That's a certain type of the Queen's English going back quite a while, despite the very important things we're doing in the current era. I think there's going to have to be other solutions to that problem, because I think the hunger for data is not going away, and I think what we at the BBC are thinking a lot about is how do you give consumers and audiences more agency in who uses that data and how they use that data, and so they understand the transactional nature of what they're giving and getting in return. And I think if we crack that, you start to, I hope, open up big data sets for a wider consumer base to research off, because there are companies out there that have these data sets. The question is, do consumers know that that's what they're handing over when they serve the T's and C's, no thank you. So, in terms of CogX 2020, that's really the question that we're really interested in discussing, which is what does the next phase of GDPR, data portability and data agency mean for how we develop these tools and these technologies going forward, because we're just at the apex of that at the moment.
So ethics and data privacy is something that's really come in a lot over the past couple of years. I see a lot more discussions about it now than I did back then, because we're starting to realise the impact of all these systems on society and how people react to them. It's not necessarily how the developers of the technology anticipate that people are going to react to them. So have you got thoughts about sort of concrete ways to address data privacy issues and these ethical concerns that people might have in using this technology?
So I can go. We have a live research project at the moment that is trying to make a physical manifestation of people's data. So we'll put it in a data box. I believe there'll be a blog going live today if anyone wants to look it up. And of course, it doesn't have to be a physical manifestation. All this data sits in the cloud. But by giving people a physical object they can keep in their home and said, this is the guardian of your data, we're trying to research how their willingness to give and take from that pool of expectations and the value exchange changes. And that's just very much the beginning. At the moment, it's based off data sets that we own around, consumption data of audio and video, but we're really interested in expanding that out to understand what does that mean for financial data, what does that mean for travel data, etc., and how can we create an ecosystem here where you have both agency but value in a physical rather than metaphorical form.
Yeah, I think there's also a bit of a give and take between, the user and then the company which actually gets their data. So a lot is also about educating the user what happens to their data. When I look at the Amazon Alexa data which we got, which is very much restricted to us as a university, and we have very strict advice from Amazon not to share this data because they have, issues about consumer privacy and they take it very serious. On the other hand, looking at this data, I do think that users don't really know that their data actually gets hosted and looked at and retained. Just looking at what people say to their Alexas at home, sometimes think, well, you were actually warned that you talk to a university bot and you still say these things. So I think there's a bit of an education to be done, similar to nowadays children at school actually get taught how to use social media. What to post on social media, what not to post on social media, what gets used, what the data gets used for, and all the privacy settings. So for example, Amazon released a function where you can tell Alexa to delete all your data from this day or delete what you've just said. I don't think a lot of people are aware that these options exist. And then again, it's also up to the companies to actually advertise these options and make them available to the user. So I think there's some public education to be done, maybe even going into schools and talking to people about these things.
So yeah, I've been into schools and talked to children, and they're always very interested in these issues, and they're very interested to learn that technology is not as foolproof as it seems, that there is, and they pick up on these ideas that there are people behind the technology building it, and there are assumptions built in that aren't necessarily transparent when you're using it. So I think it's a good point that going into schools and teaching our children is one way to do this. So we've got a couple minutes left, I think, of our panel. So I wanted to finish on looking towards the future. So as I said at the beginning, some of this technology still is, there's been a long thread of research in voice and language technology for many years, but it's really come into the mainstream in the past 10 years or so. And so if we look maybe 5 or 10 years into the future, are there things that you think will exist then which don't exist now? What would you love to see in the future?
So one of the things I'd love to see is somebody once requested me, they said they wanted a speech-to-speech translation device, but not for the major languages in the world, but for them to go to Africa and have a conversation with someone in Africa. And one of the big difficulties there has been that we don't have translation from languages to the African languages, but maybe we do have something in between. And I think there's exciting technology that maybe not there in 5 years, but certainly in 10 years, I think we'll see the world being much more connected, whether it's through speech-to-speech translation, through taking audio and video that's about Ebola in, Tamaric and Telugu, and just gathering that data together in whatever language you need it to be.
Sounds exciting.
I think there's an idea of anticipation and conversation that's sort of coming to it at the moment. You haven't talked about the fact that you have to speak to one of these things to get something out of it in the first place. I think there's a really interesting thing about if we could build it into our lives and have it speak to us and remind us of things. And then you think about the societal support for that in education, in care homes, in medication. You understand if somebody can support and actually assist my life as well as taking instruction. There's a really interesting killer app there.
Yeah, I totally agree with you. I think assistance is key. So what I really want is a secretary which manages my life for me, which knows me really well, which organizes my meetings, which manages my phone calls, which summarizes my emails, and tells me what's on my schedule for today and provides me a nice summary of the news which I'm actually interested in. And I think that's totally reachable within the next 5 years, that we will all have this private secretary on our phones or in our smart speakers. So I think that's something we're currently working towards too. And there's still a few clinches in terms of, how these systems are actually working in terms of the fluency, but especially the function of them operating over large data sets. We've talked a lot about how they learn from large data sets, but I think one of their benefits is that there are filters, a filter sitting on top of large data sets where they're able to summarize data for us. Just, imagine your inbox at the start of a day. If they could point out to you, all of these emails are actually not important, and here's a short summary of all the emails which are important to you, that would be a big, big help. Similar news, politics, so that's where I see the real value in these voice assistants.
I see a 4-day week coming on. Perfect.
That would be great. Definitely sounds very exciting. I know that means we will sort of integrate this technology together. We'll be able to link it up with different aspects of our lives and be able to use voice to just do things more effectively in the future. Which, again,
ethical aspects become even more prominent if you have this vision in mind. You want to make sure that it's not going to be creepy and finding all sorts of things and sharing these things which you don't want.
Yes, definitely a challenge to not overreach, I think, and to make sure you're building responsibly. So, well, thank you very much. This is all really interesting. We're at the end of our slot now. I think we'll be hanging around. There's a Meet the Speaker area outside somewhere. Maybe Libby can help point us in the direction.
Yes.
So thank you very much.
Thank you very much.
Thank you.